Hello there, Avalon grade 7 to 9 class. My name is Mr. McGee. You might recognize me from such films as Tara's Dad and Junior Canadian Rangers, or possibly you know that I'm already a teacher and I work at Port Hardy Secondary School where I teach metalwork, drafting, mechanics, and a little bit of other stuff as well. So Miss Mendoza and Miss McGee came up to me with an idea that I could help them with on how to give you some experience in shop building classes like I teach at the high school in your own classroom. So that's what I'm here for. And what we're going to do is we are going to together through this video build one of these, which is a birdhouse. It was designed for house swallows, and we're going to go through the process of how to build one, and then you're going to build one yourself. Now, granted, we can't bring tools into the classroom like you're going to see used to do this, so all these are going to be pre-cut and drilled and ready for you to assemble, but you're going to follow along with me as I build one of these from scratch so you can see how it's done. And on that journey, we're going to learn about tools, safety, why you choose certain things over other things, and just to give you a rough idea of what it takes to build something. To begin with, we always design our projects, and that's what I do in my own shop with my own students. So we're going to head over to the computer now, and I'm going to show you this drawn up in a program called Fusion 360, which is what I use, and we'll look at how to turn that into a set of plans that we can use in the garage here to build this out of the various materials we're going to use.
Alright, here we are at my computer, and this is what's called Autodesk Fusion 360. And I have the education license because I'm a teacher, and any student can get an education license for a year and then renew it as long as they're a student. And it's a really great program where you can learn to draw and do all kinds of crazy things. So in this case, I've drawn the birdhouse that we're going to build ahead of time. And I've assigned it a couple different textures so that we can see each board and how it's going to look. But what you can see is we have the front entrance where the bird goes in, a little dowel to stand on. Got the four sides, we got a top, and we have a bottom. Okay. So when you're drawing anything in CAD software, you always if you're going to do it in 3 dimensions, you're going to draw all the parts in their positions. And this software is pretty cool because it has the front, the roof, I've labeled them left, back, dowel, bottom, right, so I have all the parts, and I can turn them off individually so I can look at each one. So if I wanted to just look at the right part, I could look at it, I could spin it around. If I wanted to see how big it needs to be, I can measure it, so it's going to be 3.313 inches because I have it set to inches. That's how I learned, and that's so. But it could be set to centimeters as well, or millimeters. So it's really handy. So I'm just going to turn all these parts back on. The other thing that we can do is we can use Fusion to just get our ideas on paper or any CAD software, and even just regular paper. Just draw it by hand. Just sketch out an idea. It can be rough, it can be super accurate like this. Either way, it gives us the opportunity to plan ahead, figure out what we need to do, materials we need to buy, that kind of thing. I'm not going to spend too much time on this. This is not meant to be a tutorial, just to kind of show you how it works and how I got to where you are. So I took common pieces of material that was available in the pallet woods, and then I created this. And once I got the birdhouse finalized, then I created the drawings that you have in front of you, and I did that by File, New Drawing, from Design, and I created a template called Project X template, and that's what and it creates this new page, and it gives us our birdhouse. So then I was able to place different parts on there. And once I placed the parts down, I could then, it creates once I place it down, it just shows us the front, and I was able to add dimensions to it so that I knew exactly what size to cut, and then I used those drawings to cut every single piece that you're going to see in the video as we go along. So once it was done, I just exported to a PDF, and then I get this particular, I get a PDF that I can then print off, and that's how you got it. It's important to have a drawing when you're working on something. So let's open up one of the let's look at the left. So this is one of the sheets that's been printed off, and the reason why you want to have a drawing or a print as we call it is because it tells us something. Now ignore this little triangle here. It's just telling me that the dimension's been modified, and it doesn't matter. But this print is a universal language. You could give this print to somebody in Germany, and they might not be able to read English, but they can take this and they can see that, okay, so we're looking at this particular part, we're seeing it from the 3 different directions, the top, the front, and the right side, or whichever or orientation, but they can see 3 different sides of it. They can see exactly what size a hole is needed here, a number 8 countersink through. Alright, that's for the screw to fit in. You'll learn more about that later. We can see it's 1 5/8 inches from the edge, 1/4 inch from the bottom. So that person could put that hole in the exact same spot. We have our length, our width, our angle, our thickness, everything's there. And then we have what's called our title block here, and it tells us a whole bunch of information. So what's important is the notes section here. All holes shall be pre-drilled with a number 8 tapered countersink drill, so they would know what tool to use. All screws shall be sunk flush with the face of the board. Minimum thickness shall be 1/2 inch. Maximum material thickness shall not exceed 5/8 of an inch. So we can see it was drawn by Kevin McGee, the date, the scale. Because we can't fit this entire drawing onto a sheet, that would be impossible. So we'll have to look at the revision. And the revision tells us what version it is. So let's say I needed to make a change, and let's say I were to change this board. So it needs to be 10.5 inches. I would then change this from revision 1 to revision 1.1, and then you know that that's the most current. So you always want to use the sheet that has the highest revision number. We have a drawing 3 out of however many drawings there are for the project, and this is sheet 1 of 1. So just one single part could be so complex that there's 3, 4, 5 sheets to it, and you just have to make sure you know that. So at any rate, that being said, that is how you got the sheets in front of you. And the other cool thing with Fusion 360 is we can animate things. So let's have a look at that. So this is the animation side of Fusion 360, where you can animate things so that you can see how they go together, and so you can see them, all the parts exploded, and then how they fit. So I created a video using this section, and this is what it looks like. So this is, I'm playing this in AVI Media Player, the video I created, and you can just see how each part flies in and joins up. We're not going to assemble it in this order, but it was just the way I had to animate it. So now you've seen how all this was accomplished. Let's go back to the shop and build this.
All right, so we've just come back to the garage from the computer where we drew up our birdhouse and generated the plans that are going to allow us to build this. So we have determined through building the plans and myself ahead of time, we're going to be building the front, the back, the left, and the right side out of pallet wood. And we're going to be building the top and the bottom out of some cedar boards that I got from the local hardware store. So the first thing we got to do is we have to prepare all of our materials. And they're all going to be the same thickness as we know from our plans. They have to have a minimum thickness of 0.5 or half an inch, or 5/8 of an inch maximum thickness. So the cedar boards are already at that thickness. What I have here is 4 pieces that I've picked off of a pallet that was cut up. And I'll put up a picture of a pallet right now in case you don't know what a pallet is. This is what a pallet looks like. Things are shipped on it. And you can get them free if you wish to build things out of. They just take a bit of work. So after cutting out these chunks of wood, we're going to need to clean them up and prepare them for the project use. So the first thing we have to do is get them all the same thickness. So these are all going to be of varying size of thickness. This one here looks like it's a little bit thicker than this one. And that's because they just use rough sawn scrap wood to build pallets that they can't use for anything else. And there's no real way to clean that up. So what we're going to do is we're going to set up a thickness planer, and we're going to mill these, is what the terminology is, and we're going to turn them into some beautiful boards. So let's set up the planer. All right, so this particular tool is called a thickness planer. All right, so what it does is that on every board there are 6 faces. So 1, 2, 3, 4, 5, 6. And what it's going to do is it's going to clean up the 2 wide faces, this one and this one, and it's going to shave off a layer of material. This particular planer has 3 blades that spin very fast, and as the wood moves through, it just shaves that top layer off. And then we lower the cutting head with the handle here, and we do it again, and we just shave off one small layer at a time until we end up with the thickness that we desire. Part of the curriculum for ADST, which is the term for shop, is discussing a little bit about tools and what makes a good tool. So this is what's called a lunchbox planer, because it's portable. It can be picked up and carried around versus one that's bolted to the floor. So this is a homeowner's tool. It's not really a industrial tool, but it does the job. It has an in-feed table and an out-feed table where the wood goes through. It has a Indicut on this particular one that tells you how much you're taking off, a scale that you can use to roughly identify the thickness that the wood is at, although you still need to measure it with a tape measure, a lock to lock it in place for each cut, your start and your stop. And this particular one has a lock you can take off, so it cannot start without this in place, so you can lock it out so that nobody can use it. This particular brand, Rigid, is my go-to brand simply because it has a lifetime warranty on it. So once you buy it and you register it online, if anything happens, they will fix it or replace it free of charge. I have had to do that already, and it does work. So I always recommend this particular brand for my own personal choice. On the back side, we have our power cord that comes out, and we have our dust collection chute. And then we're going to learn a little bit about safety here in a second, and why it's important to have dust collection. So with all power tools, we have to make sure we're using them safely. So the planer is a fairly safe tool to use, so long as you don't stick your fingers under the cutting head here where the blades are spinning. All right, so as we're moving wood through it, we're going to stop and we'll come to the other side and pull it out. Which means that when you push the wood all the way as far as you can from the front, if there isn't anything sticking out the back, the wood is too short to push through. You have to have something here to grab on and pull. The other thing to be concerned about is hearing. Planers are loud. They are brutally loud. Especially the straight blade planers like this one. There are helical cutting heads that are quieter, but this guy's loud. So we're going to be wearing hearing protection when we're using it. And then there's dust collection. Planers throw out a lot of shavings. And I'm going to run the planer without my dust collection on it so that you can see just on one board, just so you can see how much it shoots out and why it's important. And then we're going to switch over to the dust collection system that I've built for home use, and it works really well. So to start, we're going to plug it in, and with any plug-in power tool, you want to make sure the cord is not damaged before you plug it in, because if you plug in a damaged cord, you could have an electrical fire or shock yourself with electricity. And worst case scenario, you die from electrical shock, which is called electrocution, so we don't want that. So, we're going to set this planer up. I'm going to open the garage door for dust issues, and we're going to get started. So, tune in, and we're going to get going. So when you're planing lumber, and you don't have a jointer, which is a different tool that is really beneficial to use first on at least one side of the board, we're going to start off by putting the boards in so that if they got a curve or a cup, that the hump portion is up. I'll throw a picture on the screen right now of what that looks like. So, well, let's get going. So as you can see, lots of chips, and just gets all over the place. So as you can see, this is the dust port, lots of shavings coming out, okay? So we need to set up some sort of dust collection that will collect as much of it as we can. In a home shop like you probably have, it's, you know, you're not going to really have expensive dust collection setups, but you can get away with building your own. So what I've done is I've got just a garbage can with a garbage lid. I've got a piece of screen here that allows the air that's blown along with the shavings somewhere to go, and then just have a piece of dryer venting hose to the dust collection adapter that just goes on the front of the tool. We do need to screw it on so that it doesn't come off using a hex head wrench and the bolt that comes with it. And to build this portion here came with the planer, but everything else is just built out of stuff from the hardware store. So I've got just a plumbing adapter here that slides onto it. I've just taped on the ducting, and it just goes down to more plumbing adapters down here. So it works pretty good. I mean, we still get some shavings come out on the table, but I would say that 90% or more of the shavings end up into the garbage can. So for your own interest, you can see that this garbage can is empty. It's got some junk, whatever, in it, but it's empty. We'll see how much shavings we get by the time we get our lumber to the correct dimensions. All right, so we are now done with the planer. We've planed these boards down to the proper thickness, which is just about 1/2 inch. I'll show you with that tape measure in a second. You can see the boards look quite nice. So we've got 2 faces of the boards cleaned up. This one here, you can see there's some rough edges here that'll come out when you're sanding, but that's just tearing of the wood. Sometimes you just can't help that. Also, if you rotate the wood and run it through the planer in a different way, sometimes you can avoid that. I ran this through in both directions, still wouldn't come out, so there's not much you can do about that. But we'll just use this surface when we're making our birdhouses. Our thickness is just over 1/2 inch, which is fine. The only thing left to do on these boards is going to be cleaning up both ends and the sides here, which we'll do in a second. But as promised, how much shavings did we get out of that? Well, let's have a look. Open it up. And as you can see, there's quite a bit in there for just what little planing I did. So that's stuff that's not floating in the air, getting into your lungs, and or tripping over and slipping on the floor. So, and it makes a good fire starter too if you need to start a fire. So there we go. So we're gonna put the planer away, and then we'll have a look at the next tool. All right. So as I said before, we have 6 sides to clean up before we can use this board. We have 2 edges now, and we have 2 ends that we need to clean up. What I need to do is decide which am I going to clean up first. If I were to come over to my 12-inch sliding miter saw here, which would clean up the ends, we're referencing off this edge. So if this edge is wrong, these ends will become wrong. So we need to make sure that these are first. So that's why we're going to do it in this order. So to do that, we're going to use a 10-inch table saw. I'm sure you're starting to see the trend now. Everything is orange because I love my orange tools. So all I'm going to do on the table saw is I'm going to pick one edge to start with because I don't have a jointer. Normally you would run this through a jointer and clean up that edge, but I don't. So I'm just going to pick, this is my good edge. And then I'm going to set my fence, which is this guy here, to just shave off the side of the board. And then I'm going to run the board through. Now, let's talk about some safety. The table saw is the most dangerous woodworking tool. More injuries happen on the table saw than any other tool in industry, or in the home. So we got to make sure that we're safe. We do that by keeping our fingers away from the blade right here. We are not going to touch it when it's running. We're not going to get our fingers near the saw. The general rule of thumb is we have a track here. All right. If running the material through the saw puts your hand either over top of that track or to the left of the track in this area, you need some sort of device to push the wood through, not your hand. A push stick or a push block, in this case, a micro jig. The tool, the blade height should not be higher than the material, only just enough for just a tooth's height above the material. And having the fence is very important. You cannot freehand cut on a table saw. Your material will twist, it will bind, it will kick back at you. And usually what happens when you get a kickback is it drags your hand into the blade. So all those things are very important when we're looking at the table saw. I can't stress it enough. Do not use a table saw without the supervision of a parent or a guardian. So I'm going to be in the danger zone, so I'm going to need to use my push block. I want to make sure my push block is set up so that I don't, or for one thing, I don't want to run this through the teeth, so I'm going to move my plate out of the way, and I'm going to, actually I'm just going to take this right off. Sorry, give me a second. Okay, so just take that off. Now I'm ready, and this is what's going to allow me to push it through without getting my hand near the blade. I'm also going to want to apply a little bit of pressure to the side here, so I'm just going to grab a piece of scrap wood. I've got a whole crate full of it out here that I can use just to help me guide it through. I'm going to fully mill both of the wider boards first, and then I will adjust it to do my narrow boards. So it looks like this. So now we have one nice edge here that we're going to be able to use now against the fence to clean up this side. Not going to worry too much about this chunk missing because we're just rough milling all these boards into usable pieces, and then we're going to cut them to their final dimension according to the plans. That's just how I like to do it, rather than milling them to the dimension of the plans right away. Because sometimes you have to make changes based on cracks that show up after you've planed them or milled them, and you've got to change that. So I'll quickly do the other two sides. So now that I've got the good side here up against the fence, I just need to move it over enough to slice off that edge. So I'm going to release the lock for the fence. I'm going to slide it over, and I'm just going to laser eyeball where the wood is. You'll notice that on the second pass, I didn't use my other push stick. This gripper block is really good at something new I've just started using, and just didn't really feel the need for that. It was nice and stable. But always use a good push block. We don't want things to get cattywampus on us and fly off to the side. All right, so here we go again. Alright, so now we have a board with 4 finished sides. We just need to clean up the 2 ends over at the chop saw. I'm just going to finish up by doing these last 2 boards, and then I'll meet you over at the chop saw. So a little bit of safety. Again, we're running even narrower material through, so even closer to the blade. So now I've got my support piece on my push block, and that's just going to allow me to push the block, push it through, and this supports my push block. Alright, 4 pieces of wood with 4 sides done. Let's head over to the chop saw and finish up the ends. Okay, so if you're setting up a little home workshop, aside from a table saw, a sliding miter saw is an essential tool. Alright, this one, again, Rigid brand, not a sponsor yet, but my preferred brand. A sliding miter saw means that it slides back and forth, okay? It's miter just refers to the fact that you can change the angles. We will all be changing this at a later time. And it's a compound miter saw because you can actually change this one up here as well and adjust the different angles. Alright, this has a very poor dust collection system. I've got a sacrificial fence set up here right now, just allows me to cut cleaner cuts. And what we're going to do now is we're going to just drop our wood in here. We're going to come down with our blade, and we're just going to clean the ends up. This has got a little bit of a crack on the end. I'll cut the crack off. And that's going to create a nice, clean milled board for us to start our project from. Safety on this guy is fairly simple. Your material must always be up against the fence here. If you try to cut it with it back out here, it'll catch and it'll flung it to the back. Probably pinch your fingers. Okay, we don't want that. We want to have our hands up on the handle here and holding our board. The rule of thumb is your fingers should never be on this orange plate here. This is called a throat plate. And your fingers should never be touching that. So I can have my hand here, but I don't want to have my hand anywhere here. Like the table saw, don't use one of these without the having a parent or guardian present. So what I'm going to do, all I'm going to do is I'm just going to, first of all, I'm going to adjust my sacrificial fence for this particular job. I'm just going to, and then just cut a new cut. And I just, as a starting point, I'm going to slide, I'm going to put my board up against the fence, I'm going to slide it over to roughly where it's, I think it's going to cut. And I'm going to bring the blade down, and I'm just going to position the wood, I'm going to cut about thickness of the blade off. In fabrication terms, the thickness of the blade is called the kerf, K-E-R-F. Little vocabulary there for you. And we're just going to remove that amount of wood. So with chop saw, proper use is you get it spinning first, and then I'm going to lower it, I'm going to pull it out, I'm going to lower it down, and I'm going to push back and cut. Pull it out, wait until the blade stops before I move anything and reach in there, and then I'll take my material out, I'll flip it around and do the same thing. So this is how it goes. Wait for it to stop, flip it end for end, and same thing. And there we go. We have a nice clean end of our board. All 6 sides are done. We can now start our project with this piece. We'll just finish off the rest and then we'll be back. Alright, and we're back. We've got all of our boards ready to go here. Like I said, the cedar roof and floor is on an already pre-milled piece of lumber, so we're good there. Now, I know you're probably sitting back there thinking, well, what kind of blade are you using on there? Well, that's a good question, Tara. I'm glad you asked. So, I'm just going to quickly talk just very briefly. There's 2 types of blades you use on a saw, a finishing blade and a general purpose blade. This is a general purpose blade. And these particular blades, these green label blades, I buy them at Hardy Builder Supply. And I think they're the best way to go. They're an exchange of blade system. So every time the blade, you pay a little bit up front to buy into the system. And then when the blade gets dull, you take it in, you exchange it for a replacement that's pre-sharpened, ready to go at a discounted price. And they're very high quality. So if you're buying tools, I highly recommend that. Alright, welcome back. So now what we're going to do is we're going to cut this board to length, to width, on the chop saw, on the table saw again, and then we're going to lay out and drill all the holes. So this is the front of the birdhouse. So on your screen right now, you should see a picture of the drawing, and we can see that we need to cut this to a length of 8 5/8 of an inch, and a width of 5 1/4 inches. So we're going to lay that out right now. So to do that, we're going to use a tape measure, a pencil that I stole from Tara, and a square. 2 different types of squares, a carpenter's square and a speed square. Either one will work. So I'm going to take my tape measure and I'm going to hook it onto the end. Always make sure before you use a tape measure that the end of the tape measure isn't bent. Had that problem recently. Not happy about the quality of these tape measures. So I'm going to measure off 8 5/8 of an inch. And when I measure just going to come around to the camera. I make a little V. And we'll just get it to come into focus. So when you measure, it's always good to make a little V. The measurement being the point where the two lines come together. And that's where we're going to put our square to line up. So I'm going to take my speed square, and I'm going to line it up with the point, and I'm going to draw a line. And that's where I'm going to cut my board. If I want to make sure everything is lined up, I can measure it again. Everything looks good. And then again with the carpenter's square, we can also use that to do the same thing. We're going to use the carpenter's square for laying out the holes a little bit later. It makes things a lot easier. So now I need to cut that board off right across there. And then we need to rip it. So that's called a cross cut because we're cutting it across the board. All right, or across the grain. The grain is going this way. And then we're going to rip it with the grain. So I'm going to measure off 5 1/4. And the board is actually 5 1/4 spot on already. And that, of course, was a purposeful thing behind the scenes that you didn't know. These boards were picked because they would come out at 5 1/4. All right, so I'm just going to cross cut this on the chop saw right now. So what I'm going to do is I'm just going to line the tooth up with the correct side. I should point that out. We measured from this side. So it's always good to throw an X on the side you don't want so you know which side of the blade to cut on, or which side of the blade on the line. If I have my blade on this side, my board will be too short because of the thickness of the blade, the kerf. So we want the blade to be on this side of the line. So I'm going to line that up. And then I'm going to cut it. Now my board is, after making the cut, I can still see a little bit extra material. So a little trick with chop saws is that you lower the blade, and you just push your board over till it touches the blade, and then raise it and cut it again. And by doing that, just because of the way the blade is made, the teeth are slightly wider than the sheet metal of the blade. It'll take off the tiniest little bit, just shaves the tiniest little bit off, and now we're at the proper length, which is 8 5/8 by 5 1/4. So there is our front. Okay. All right. So now that I've got the starting point of my board, the roof is sloped so that water comes off the slope of the roof. And that means that if you look carefully at the front here, this is angled, all right? So we need to cut an angle on the top of this board. And that's a 22.5-degree angle. And that's why the chop saw is going to be so handy. So what I'm going to do is I'm going to set my chop saw to 22.5 degrees. And then all I'm going to do is I'm going to cut the end of this board. And I'm going to keep cutting until the blade just comes down the back side of this. So the back of the board will still be 8 5/8, but the front of the board will be a little bit shorter because of the cut. So it looks like this. So here's our board, and we can see that it's got the angle cut to it now. So the back of the board is 8 5/8, and the front is whatever it needs to be because again, it's just a 22.5-degree angle. So now it's time to lay out our holes. So let's start out by laying out the location of the hole that the bird is going to enter in. When we look at our plans say that the hole is 1 3/4 inches in diameter. We don't have to worry about that. We just have to mark the location of the hole, which is 6 inches from the bottom. So I'm going to make a pencil mark. And it is 2 5/8, or the exact center of the board, in the other direction. And I'll just use my square to make a little centering mark, or a plus sign, or an addition sign, depending on how you know it. And that's where the main 1 3/4 hole will be. The hole for the dowel that he lands on right here needs to be 4.5 from the bottom, so I'll measure that. And 2 5/8 in this direction. At this point, you're probably wondering, what is this 2 5/8, 1 3/4? Oh my goodness, what's he talking about? Well, this is called the imperial measurement system. You're familiar with the metric system because predominantly Canada is a metric country, but in construction, we generally still use the American or the imperial system, which is fractions. So it's a good skill to learn because if you go into construction, that's what you're going to be using. So we have our location for our 2 holes now. Now we have our 5 countersink holes. So let's talk a little bit about the countersink. What is this countersink thing? Why do we use it? So let me grab what we need. Okay, so let's talk about the fasteners that we're going to be using for this particular project. This is a green, which means it's a deck screw. It's used on decks outside. It's an exterior grade screw, the green coating. You can also get a brown coating, same thing. It just matches whatever material you're using. So green ones are generally used on pressure treated, because pressure treated lumber is kind of greenish, and brown ones are used on deck boards. It's an exterior grade screw. It's not going to rust. That being compared to the exact same thing in gold. Gold is a construction screw. It's exactly the same thing in all shapes and sizes, other than it's gold, which means it will rust if you use it outside. So that's why we're not using the construction screws. So you'll notice the head of the screw is tapered and flat. That's a countersink, which means it sits flush. So as you can see on the birdhouse, all these screws are flush, sunken down in against the surface of the wood. Number 8 just refers to the shank size. So on a screw, we have a head, we have a shank here, that's number 8. Okay, then we have the thread here, and the point, and the distance from the point to the end of the thread is called the thread length, and then from point to the base of the head is the grip length, or how thick of wood can you stick together. So we're using a number 8 just because it's about the right size for a 1/2 inch thick material. We're using an 1.5 inch long screw for a very specific reason. You'll notice that this portion right here doesn't have any threads. Okay, it's just the shank. All right, that, if you measure it, is just under a 1/2 inch. So we're using 1/2 inch wood that we're going to be screwing to another piece of 1/2 inch wood. We want to make sure that that unthreaded portion is from, when we put it on our wood like this, when it's flush, we don't want any threads to be in the first part. Because if there is threads on that wood, then it won't suck the two together. The threads, in order to suck two pieces of wood together, the thread needs to be in the second piece only, which is why we have picked this particular size and this particular length. Probably too much information, but there you go. Now you know. So a number 8 countersink drill is what we're going to be using. The plans say a number 8 countersink through. All these countersink holes are going to be through holes, which means we're drilling all the way through our first piece of material. This particular tool goes into a drill. It has this portion up here is a countersink portion. This will cut an exact duplicate of this head in the wood so it sits flush, and we don't so that we don't have it sticking above. And the drill bit here is going to drill the hole. Now it's tapered, okay? You'll notice that a screw is tapered. It gets thinner as it goes to the point. So does the drill, and that is what's necessary. So it will drill a hole in this wood with a countersink and a through hole all the way through that this screw will fit into. And that's going to help us prevent the wood from splitting, and it's going to allow us to suck the two pieces of wood together, and it's going to allow us to have the screws flush, which just gives it a more pleasant appearance and a more professional appearance. It's just how it's done. I don't make the rules. I just follow. All right, so we need to lay out those countersink hole locations now. All right, there is 2 in the bottom corners here, and they are 1/4 of an inch from the bottom and 1/4 of an inch from the sides. So, as you recall, I said that we're going to use this for another purpose. And what's handy about a carpenter's square is that you can slide the blade up and down wherever you want by loosening this thumb screw. I'm going to set this using the scale on it, because it has a scale. And I'm going to set it for 1/4 of an inch. So just slide it down until I get 1/4 of an inch, which is right there. I like to do an idiot check by just making sure that it's actually 1/4 of an inch, which it is. So now what's handy about that is I can just go hold this against the side of my board, and I can mark, and then I can rotate it, and I can mark. And there is I've got a centering line for my screw hole, 1/4 of an inch from each edge. So it's about knowing what tools you have and how to use them to make things efficient. All right. The 2 top holes here are the same dimensions, 1/4 of an inch from the edge, 1/4 of an inch from the edge, and then from the top, it's a little bit harder because there's an angle there, so I'm going to have to measure those. It won't work. And then there's one in the center at the bottom here. This one holds the bottom or the floor of it, so I'm going to mark that. I know that 2 5/8 from the edge is the center because we did the same thing for that. And then I will just measure from the bottom down on these ones. You'll notice that I often go like this with my tape measure. This is what's called bearing an inch. The end of the tape measure is hard to read. The tape measure has some wiggle on the end, which is supposed to be there, contrary to popular belief. You do need this movement here. So I'm just going to pick just any old measurement. I'll start here at 11, and then I'll measure 1/4 of an inch. It's more convenient. It's easier for me. I can rest my hand on here, and I'm not trying to fight the end piece that's moving it. So we've laid out all of our hole locations on this board. All right. So now we can drill it. I'm going to show you 2 different ways to drill holes. I'm going to drill using a hand drill, and I'm also going to drill using a drill press, just to give you a little bit of exposure to tools. So let's start with the hand drill. So here's a hand drill. No surprise, orange. And I've got my drill bit. I'm going to put my drill bit into the drill. A drill just uses 3 little jaws here, 1, 2, 3, and a collar that you rotate the collar and it tightens it up. Some collars are keyless, like this, where you can just use your hand to tighten it up. And other ones, like my drill press, will use a key, and we'll talk about that. This is a cordless drill, which means it uses a battery. And cordless tools are great under certain circumstances, at least I feel that way. And part of the reason why I buy the Ridgid brand is because if you buy a drill and it comes with a battery, the battery is eligible for lifetime warranty as well. And we all know that batteries don't last. So it's nice to have batteries replaced free of charge. The safety on a drill is pretty straightforward. Don't get your fingers in the way of the drill bits. Okay, drills will go through fingers. I know I put a drill through this finger just like that once when I was much older than you guys. And I still have a scar to prove it. And I have no feeling in this finger tip. So makes typing irritating. You also have to be concerned about the drill bit getting stuck. If you're drilling and the drill bit stops, gets stuck, it jams, which happens more with metal than it does with wood. This guy is going to spin on you, and if you're not prepared for that, it can twist and break your wrist or your elbow or your shoulder if you're not careful. So you want to brace it against your body when you're drilling harder materials like metal. It's not going to be an issue with this wood. I don't want to drill into my nice work table. I want to make this thing last as long as possible because wood costs more than gold, it seems, today. So what I'm going to do is I'm just going to get some scrap wood from my scrap bin here, and I'll use this. I'm just going to put it on there. That way I won't drill through. That's almost going to go through, so there we go. So what I'm going to do is I'm going to drill the bottom 3 holes here using the hand drill, and I'll drill the rest with the drill press. It's pretty straightforward. Put the tip of your drill bit right on the crosshairs or the plus sign or the addition sign, or whatever you want to call it. We're going to pull the trigger. And then we're just going to make sure we're drilling straight up and down. And we don't want to be drilling crooked, okay? So we just want to drill straight up and down. We're just going to slowly go down. To pull out, get rid of the chips. It's called peck drilling. Go down again. So we've drilled the hole now. Now we're going to start drilling the countersink portion of the screw hole. Alright, and now we have a countersink that the screw head will fit into. So we're going to do the next hole, but we're going to bring you right in close so you can see what's happening. Alright, so let's do the next one. Drill bit directly on the mark. Make sure we're straight up and down, and drill. Drilling our countersink now. And how deep you drill your countersink depends on your screw head and your experience. So my experience tells me that that's probably deep enough. At a certain point, it goes from being a tapered hole to having tapered hole with some straight vertical sides. I can see that's just happening there now. All right, let's drill our last hole over here, and then we'll move to the drill press. That hole moved a little bit. Unfortunately, I hit a knot or something, and it just shifted over a little bit, but it'll be fine. And that's what happens when working with woodwork. You just can't get everything perfect. Wood will sometimes stop you. All right, let's take out the countersink, and let's move over to the drill press. Okay, so over here at my drill press, That's just this one. This is not an orange drill press. Maybe one day, but this is just a used drill press I picked up off Fleabay. And so a drill press is handy because it lets you drill controlled, straight, perfect holes. It has a table. Now this is a table that I built. It has a metal table underneath that it came with, but I built this drill press table because it lets me, I have a fence on here I can move to adjust and set up repeatable holes. It's just a fixture, it just helps out. I won't be using it on this, but it's helpful. Replaceable insert in the bottom. As you can see, it gets chewed up from drilling. So the key differences here is, of course, it's stationary. It has a chuck with 3 jaws, just like before, but it does have a key on this one that you have to stick in and tighten up all 3 holes. On a drill, all 3 holes have to get tightened up, otherwise the drill bit will spin. Alright, it has different belts, speeds to change depending on what you're doing. It's fine on the speed. It's set right now for the big hole for the bird to go in. We're not going to change it just because there's not much point. And it has a quill, so you just raise and lower the table to do your drilling. It also has a removable lock, just like the other tool, so that people can't use it. And what we're going to do is we're going to drill the other 2 holes. So safety on this, just keep your hands away from the spinny bits, because that's what hurts. And the other big thing is that if you're drilling anything other than wood, it needs to be clamped down to the table. And if it sticks out a long distance, if I were to drill something long like this, I would not want to stand on this side of it because it would spin and hit me. I want to stand on the other side so it spins away if that were to happen. So, drilling on the drill press looks like this. Just going to bring it down and line up our wood where we want it to be, right there. And we'll just drill and countersink. Now, one nice thing about a drill, I'll show you, is we can set a depth stop so that we can drill a certain depth and that's it. So, if I adjust my depth stop here, this means that I will not be able to drill any deeper on the next hole, and I'll get an exact duplicate countersink. And this is why the drill press is a superior way to drill things. Alright, we're back with a different setup now. We're going to drill the hole for where the dowel, where the bird lands on. We're going to be using a different type of drill bit. This is just a general purpose. They call it a jobber drill bit. It just comes to a point, 118 degree point, and just general purpose. All right. One thing I can't stress enough when it comes to drill bits, you buy quality drill bits. Don't cheap out on drill bits. Absolute worst thing you can do. You'll regret it. So I've got my mark here where I'm going to drill, and lining up that mark can be a little bit tricky. What I'm going to do is I'm just going to come in here, and you probably can't see on camera, but I'm just looking at the point of the drill bit and lining it up in that direct, this left and right, and then come down front to back. Looks good. Just making sure. You just laser eyeballing it. Now the thing is that we don't want to drill all the way through this piece of material, just most of the way. So how do we do that? Well, you can set a depth stop up on the drill press. But if you don't have a drill press and you're just using a regular drill bit, what you can do is you can mark off that material depth by just using a piece of tape. So I just got a piece of hockey tape here, and just going to cut off a portion of it. And what I'm going to do is I'm going to lower the drill bit to about the depth I want. And then I'm going to place the tape on my drill bit. And what is going to happen now is I'm just going to drill until that tape touches the wood, and then I'm going to stop. Just a really simple, easy way to do a depth. So again, we'll line up our drill bit right there. I'm going to turn it on, and then we'll drill. Just retract the drill bit to clear the chips. Go easy. And then right up to my tape. And then we get a nice hole there for the dowel to go in for the birdie to land on. Alright, so for the last part of this, we need to drill the big hole for the bird to enter the birdhouse in. So what we're going to be using for a big 1 3/4 hole is we're going to use what's called a hole saw. This is an 1 3/4 hole saw and a arbor here. And this arbor has a pilot drill that centers it. And then what happens is the hole saw screws onto it, so you can change this out for different sizes. And then it has just a little locking collar here that locks it in place. And then we're going to use that to drill our hole. So just like anything else, it goes in our chuck. Key with a hole saw, drill slow. Spin it really slow, take your time. Because we need that. Okay, so let's line my table up. So like before, I'm going to line up my drill bit. It's hard to see because the drill bit, the pilot bit, I should say, is in underneath the this guy here, but just getting low down to the table, I can see it. All right, so what we're going to do is I'm going to drill part of the hole on this side, and then I'm going to flip it over and finish it from the other side. And the reason for that is it'll help deal with tear out, and it'll give us a cleaner hole. And I'll show you what I mean by that. So I'm going to come down, and we get this pilot. We want to check and make sure the pilot hole's where we want it to be. It looks good. I'm going to come down, and we're going to start chewing away very gently. We need to lift it out. You get lots of chips on the get stuck in the teeth there, so I keep a brass wire brush close by. And just to clear the chips off of there. A little bit more. You can see how the chips load up the teeth there. So now we got a fairly nice clean cut here. But if we go all the way through the backside, it's going to tear on its way out. But we have our pilot hole now. So on a hole saw, a little trick is always flip it over and finish the hole from the other side whenever you can. So I've lined up my pilot hole there now. Turn it on. And then come down and finish the hole. And there we go. So now we get a nice clean hole on either side. We're still going to need to sand these openings. And we have the piece we cut out, which is easier to pull out if you do it this way as well. Just a center piece. So that is done. This front part is done. We can move on to the other pieces now. All right, so we're back at the bench now, and we're going to work on the back of the birdhouse. So looking at the drawing, we can see that we need to cut a piece of wood, 5 1/4 wide, which it already is, and we need to cut it to be an overall length of 11.5 inches. Then drill some holes. We need to, looking at our birdhouse here, we have on the back, we have 5 holes we have to drill with the countersink, as well as 2 holes on the opposite side to use to screw it up to a wall or a tree or something. So I'll do everything is basically a repeat of before. We're going to mark off the length, which is 11.5. Okay. I'm going to make my little V. I'm going to take my square, line it up with the V, draw a line across. I'm going to come over to my chop saw, reset it back to 0. And I'm going to saw that off. Okay, so I've got my piece cut to length. I need to lay out my countersink holes. So I'm going to use my carpenter's square again, and I'm going to mark off. They're the exact same dimensions as before. So I've got 3 along the bottom. Mark off my corner. And just measure over 2 5/8. Our next holes are 8.5 inches from the bottom. So I'll mark up 8.5 on either side. And I will measure over using my preset carpenter's square. All right. Now the top holes are on the opposite side, so I'll flip it over and I'll measure those off. They're different measurements. There's only 2 of them, so I'll just use a tape measure for that. 3/4 of an inch from the edge. Okay, so measure 3/4 from each edge and 1/2 inch down. And like that. And then just... So there is our hole locations so that we can drill them with our countersink bit. So we'll head over to the drill press and we will drill these holes out. Just it's more accurate and faster over there. And then we'll be done with this piece. So we're drilling with the countersink, and I've got my my depth stop set a little too high. So just adjust that. That looks better. Flip it over and we'll do these ones. And done. All right, back at the bench. Just double check with our print, make sure we've got all the holes and everything where we need it. Everything looks good. So that part is complete. We'll move on to creating the left and right side. Now the left and the right side are mirror images of each other. And it's just which side of making sure we countersink the one hole on a mirror image of each other. So what we'll do is we will cut them to the right length and the right width, and then we will set up the drill and drill the hole. So both pieces need to be 3 5/16 of an inch in width, which they are, because as again, everything was planned out in advance. So we do not need to rip these in the table saw. What we do need to do is we need to cut them to the right length with the 22.5 degree slope to it that is this edge here. So what we'll do is we will pick, I like this side, so I want this side exposed, and this is the nicer side. So what I'm going to do is I'm going to measure off 10 inches. That is how tall it needs to be. I'm going to mark both boards at 10 inches. Okay, and then to ensure I get a mirror image of each other, I'm just going to draw a line like this and like this to simulate the angle it needs to be cut at, and then that mark is where I will mark it at. So I'm going to come over to the chop saw and make the next cut. Okay, so we're over here at the chop saw, and we're going to cut this on that mark, on that angle. All right, so what I'm going to do is I'm going to set this to 22.5 degrees. It's right on the scale right here, and lock it in place at 22.5. And then I will take my chop saw, and I need to move my dust bag. So I'm going to line it up just a little, leave a little bit of material that I could trim off. I'm obviously cutting it on the angle I wanted, so I'll start my cut. A couple little pieces of scrap wood in there that got caught on the blade. No big deal. Alright, so it is a little bit on the long side, and I'm going to leave it a little bit long for a very specific reason that you'll see in a little bit. What I want to do now is I want to cut the same thing on this side, but you can see that that's not going to work. It doesn't matter which way. I'd have to flip it over like this, and then I can't see it. But that's okay. I'm just swing my chop saw over to 22.5 degrees the other way, and then I'll make the cut on that side. Just have to cut my sacrificial fence here. All right, so roughly about there. So if I line these two pieces up, we can see that one is longer than the other. We also call that this one is sitting proud of that one. It's more terminology in the construction world. And I left them to be trimmed off together. So what I'm going to do now is, because this one is the short one, I'm going to set the saw up for that particular angle. This is a little trick. I'm going to push both of them against the fence. I'm going to make sure that both are flush at the bottom here. And then I'm going to slide this up and till I'm just going to cut the top surface there. I'm going to trim them down to the pencil mark that I can just barely see. And I'm cutting them both at the same time, so they'll both be the perfect size. Now it's a little bit short, so I'm going to push them up to the blade, cut again. Still a little bit, I think. It's hard to tell. I think I can do it one more time. So just by pushing it to the blade, it just takes the tiniest little bit off. And now we have two pieces. Now we have two pieces that are the perfect size and the same length. And now we can drill the two holes. All right, so we're back at the bench. And so now I want to lay these out so that they're a mirror image of each other. And the parts I want, the sides I want out are exposed, and the yucky sides are down. So I need to lay out a hole in the middle on the end here. So I'll grab my stolen pencil and my carpenter's square, and just roughly in the center here, I will mark this off. And And then I will measure over 1 5/8 inches from the front. So this is the front of the birdhouse. And I'm going to measure over 1 5/8 inches according to the plan. And then pick the front. Bit awkward because I'm a lefty, but lefties are awesome. So we've got our location to drill our hole, and we'll make our way over to the drill press station, drill those holes, and I'll be right back with 2 pieces with countersunk holes. And we're back with our 2 countersunk holes on our left and our right side. And there's nothing else to do to these parts. They're done. So put them with the rest. And now we need to do the top and the bottom, or the roof and the floor. So the roof and the floor are made out of red cedar. Okay. Partially because that's what I have. And also, red cedar it makes a great roof for lasting a long time. So we need to cut those pieces out of the long board. We need to cut a piece that is 5 1/4 by 4 5/8, and then countersink 4 holes in it, and that will make our roof. So we're going to do that on the chop saw. So I'm going to grab my board. So here is the board. It is just a long piece of cedar siding that was donated, that I have just planed and cut to rough width. All right, there's a big crack chunk here, so we'll just use this end here and it'll be fine. That's all we need. So the end has already been squared off, I believe. Oh, no, the other end has already been squared off. So I will quickly square this off in the chop saw and be right back. Okay, so now we're going to measure off a piece 5 1/4 inch, which is right here. Take my square that up, and then I'll take this to the chop saw and cut it off. So it is now 5 1/4 inches wide, and it needs to be 4 5/8 inch in the other direction. If I measure this 4 5/8, this is 4 11/16. So it is a tiny bit longer than 4 5/8. Not even really worth dealing with at this stage, because we still have to cut a, as you can see from the birdhouse, because the birdhouse is on a slope, we need to cut that 22.5-degree angle, and we'll take that extra 16th out when we cut this off with the table saw. So let's go over to the table saw and let's learn a little bit about angles. So we're over at the table saw, and the table saw is used for ripping and cross cutting. We have the fence set up for ripping because we are going to rip this block through here. We need to adjust the blade to a 22.5-degree bevel. So luckily for us, this table saw will let us set it to 22.5 degrees. So we're at 15, 16, 17, 18, 19, 20, 21, 22 and a half right there. So I want to set the height so that the tooth is just above. And I want to set the fence roughly, and I just got to laser eyeball this. I'm going to start here. I'm going to run it through, and then I'm going to keep moving the fence over a little bit until I just cut the corner off. And when I just knock this sharp corner off, it'll create a new corner, but it'll be on a different angle. That'll take off that little bit that we need to in order to get the right length, or the right width, sorry. I also want to set up my block here because I do not want to run my fingers into the blade. That would be very bad. If you are worried about buying or about ever cutting your fingers off on a table saw, and you're buying a table saw, you can spend the extra money on what's called a saw stop. It's a special saw, table saw, nice saw. But if you touch the blade will stop and disappear instantly. You can look it up on YouTube. It's pretty cool technology. So everything looks good. I'm set up. So let's cut this off. So you notice when dealing with short pieces where I have to reach close to the blade, I just turn it off, wait till the blade stops, and then I reach in. Safest way to do it. So we removed our corner. I'm going to grab a tape measure. Let's see if we have the right dimension though. 4 and almost 5/8. So we'll move our fence over just the tiniest little bit. We'll run it through again. Four and 5/8 with a nice bevel on there. All right, let's go back to the bench. All right, so we're back. We have our roof now. It's gonna fit just like that. So we just have to do these 4 countersunk screws. So we're gonna do that just by laying things out again. So our hole locations are as follows. From the bottom, all the dimensions are off the bottom. I need to measure up a 1/2 inch and a half. Make a mark. And 3 and 5/8. Make a mark. The same thing on the other end. 1.5 inches. And 3 and 5/8. They're a 1/4 of an inch from the edge, so we still have our carpenter's square set up ever so nicely for this. And now we have our drill locations. So once again, I'll head over to the drill press, drill these out. You've already seen it, so won't need to film that. And when we come back, we'll have our roof finished. And we're back with our completed roof. 4 holes drilled and countersunk. Parts ready to go. So the last thing we got to build before we can start assembly is the floor. So we need to cut a piece of cedar 4 1/4 inches long and 3 5/16 deep. So grab our cedar board. We'll mark off 4 1/4. Which is right there. Mark it off with a square. And cut it with the chop saw. Alright, so 4 1/4. And then we need to make it 3 5/16 the other way. So I'm going to mark off 3 5/16. And then we'll go over to the table saw. And then we'll rip that. Set the table saw back to vertical. You can measure off 2 different ways. You can use the board and line it up with a tooth with your pencil mark. But the more accurate way is to just use your tape measure. Pick the tooth that's pointing towards the fence and mark it off like so. Chances are I'll need to trim this floor down a little bit to fit afterwards. If so, no big deal. I need to position my gripper block about there. And away we go. And that should be 3 5/16. Nothing to drill to do to that. It's just done. So we can put it over here. So that's the only thing left to cut is the dowel. I've already cut the dowel off camera. And no big deal. There. It's just cut on the chop saw. And there we go. So that's all the parts cut. And we can start looking at assembly. Alright, so now it's time to do the final assembly of our birdhouse. What I have here is a simulated package of what you're going to get. So when you get a package from your teacher, this is what you will have. So when you open up your package, first thing you want to do is make sure that you have everything. So you should have the front with the birdie hole, the back, a roof, 2 sides, and a bottom, a dowel for the bird to land on, and you should have a total of 16 screws. So let's make sure we have them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Alright, so that's everything that we need as far as supplies, or material I should say. We're also going to need something to sand it with, whether it be a square of sandpaper or a sanding sponge. There are 2 different ways that you can sand things by hand. These are 2 ways to do it. We're going to need a screwdriver, okay, and your birdhouses are all pre-drilled. Mine is not, so I'll be pre-drilling some holes as we go. You won't have to do this step. We already did that for you when we made the kits. So, and I'll explain a little bit more of that. Right now I just want to talk about the screwdriver. Now your screwdrivers are going to look differently. This is just the one I have at my house. The screwdrivers you're going to be using may look a little bit different, but they all use the same tip, which is a number 2 Robertson, and it fits the screw. A number 2 Robertson is a square head, so Robertson screws are square head. You have Phillips heads that look like stars. You have standard or slotted. Some people call them flatheads, but that's an American term, and we use standard or slotted. There's all kinds of different shapes of screw heads. The Robertson is a Canadian invention, and that's why we use it, because it's better. And the entire world, aside from the United States, has switched to using a Robertson. They continue to use Phillips and slotted for whatever reason. So that's what we're going to use to put the screws in. And let's begin. So the first thing we need to do is prep the front, because we won't, once we screw it together, we won't be able to access the inside, and we just want to make the hole that the bird is going to come in. We're going to clean that up with sandpaper, both front and back, and just make it nice so the bird can go in. So I'm just going to take my sandpaper and I'm going to sand off any of the burr. A burr is just material that's raised out, causes problems. So I just want to slightly round the inside of the door, or the hole. I guess it's the door. And same thing on the outside. I'm not going to spend a great deal of time and fill this video up with 20 minutes of me sanding this thing. It's going to take you however long it takes you to clean this up. But the main goal is we just want to make it so that the entrance to the door looks nice and doesn't have any sharp edges to hurt the bird. Because if the bird doesn't like the entrance, they won't use your birdhouse. They won't. There's going to be something like 20 other birdhouses in town that, from your class, they could go and live in. So we want to do that. The sanding sponge is the exact same thing. It's just flexible, but it'll do the job. As far as sandpaper goes, there's all kinds of different types of sandpaper: wet sandpaper, dry sandpaper, meaning you can use them with wet, like with either water or some type of oil. There is different grits, all the way from 20 grit, which is really rough, kind of like pavement, all the way up to like 3000 grit, which you might as well just sand with paper that you use to write on, because it's about the same thing. And when it comes to finishing wood, a good rule of thumb is 80 grit to start, 120 to get rid of any minor imperfections, and then 220 for finishing sanding. So I'm going to call that pretty good for my birdhouse. And we're going to move on with this stuff. You're going to make a lot of sawdust and stuff. I'd highly recommend that you try to avoid sweeping it onto the floor, making it so that someone has to clean it up. Just scoop it off into your hand and put it in the trash can. Alright, so now it's time to start assembling. So we need the front of our birdhouse, and we're going to need the two sides to start. So you'll notice on the birdhouses that they're on the sides and the floor and the back, there are these lines, and so two lines line up with these two lines. You've got a couple of single lines. The idea is that when we come to at a certain point, these lines are going to matter. They're not going to matter right now, just so you know. Everybody has a letter. All your parts have the same letter on it. Mine happens to be Z. Yours could be any letter, whatever you're given. All right, and so you can't swap your parts around. Your parts are specific to your birdhouse, okay? So don't be swapping parts around. So I'm going to start by joining the left side, and I know it's the left side because I'm looking at my birdhouse. I've got the hole here for the bird to land on with the little dowel in there, and I have the countersink facing out, all right, for the screw to go into. So I know that that is where it's going to line up. Now, this step you don't have to do. We've already done this step for you, but I have to do it on my birdhouse. So I'm just going to line up and countersink that hole. So once you put your two pieces together, you take your screw into the hole and then put your screwdriver in and start turning it. Lefty-loosey, righty-tighty. So you have to turn it to the right to wind it in. If it's not going in, you're probably turning it the wrong direction. If you're having trouble running your screw into your wood, a trick that carpenters have been using since time began is you can lubricate the screw with a little bit of wax or a piece of soap, like bar soap. If you do that, and just rub it on there, it helps, makes it slippier, and it goes in. I prefer using soap because you can wash soap away. Wax is a little bit harder to get rid of. Alright. So like I said, you don't have to do the drilling. You can just go straight into running the screws in. We don't want to drive the screws in really tight, just snug, just so it pulls the two pieces together. If you crank down on it, you're going to crack your pieces. Okay, even though we pre-drilled the holes all the way through, you still crack the pieces. And if you suck it down too hard and tighten it up and crack your pieces, there isn't anything that I can do through the camera lens. So you've been warned. So I'm going to line up my other piece. All right, there's really no way to make a mistake on this side. The key point is the countersinks must be facing out. So I'm going to line this up. I'm going to pre-drill. Once again, we did it for you. All you have to do is line up the boards and run the screws in. And at this point, you're probably like, oh, I have to use such long screws. Well, I explained that before. So you just have to have the right thread count and everything else to make it work. Now, just a bit of warning. When you assemble your birdhouse, it may not line up exactly perfect. And unfortunately, that has to do with the shrinkage of wood as it dries, and there isn't much we can do about that either. Okay. So, there are my sides and my front. Next comes the back. So for the back, these two lines go down and away from you. The 5 countersink holes face up. And same thing as before. We want to line the bottom here flush. Flush is where both parts are exactly the same. Neither is sticking out. Whereas if one is sticking out past the other, that's called being proud. This board is proud of this one. Little carpentry terminology for you. And I'm going to pre-drill this and then run my screw in. Line my bottom up on the other side now. And I'm going to pre-drill. And screw in the bottom. It's a little bit easier to line everything up if we do the 2 bottom pieces first. So while we're assembling this, just talk to you a little bit about different kinds of wood that we used in this project. There is some oak, which is a hardwood, very expensive wood. There is fir, which is a little bit harder to get, but a common wood that you find around the North Island. We don't have oak up here, not naturally. Someone might have planted oak trees. But we got fir trees. There is some pine, some spruce. We have spruce on the North Island. A couple of boards were mahogany. Mahogany is a really fancy, expensive hardwood that they used to make boats out of. And, of course, there's the red cedar. I'm sure everybody's heard of cedar before. It's a highly sought after piece of wood that we're blessed on the North Island to have an abundance of. Kind of makes you wonder though, why would they make pallets out of mahogany or oak if they're such expensive stuff? Well, on the West Coast, when we make pallets out of what we have: hemlock, spruce, fir. But on the East Coast, they have more common woods like mahogany, oak, that kind of thing. So that's what they make them out of. They just make it out of the reject wood. That is all. So there's the back put together. So now it's time to put the bottom in. Now remember we talked about these hash marks here, or alignment marks. There's 2 here and there's 1 on each side. So we've got 2 hash marks here and 1 on either side, so we know that when we put it together, they need to line up. Otherwise your holes aren't going to line up. So I'm going to push it in. I can kind of just push it down like this and just flush the bottom up. Like before, yours is already done, but I'm going to have to pre-drill mine and run a screw in. If it were possible to have left it so that you'd have to do some drilling, we would have done it, but just don't have enough drills to make that a possibility. Alright, flip it around, do the same on this side. Pre-drill. It's always good to do opposite sides, just holds things in a bit more parallel. Like I said before, sometimes when you're drilling, things shift. It's just the quality of wood we're working with, so don't be surprised if things don't quite line up. You can always sand it nicely. And one last for the bottom. If you're struggling with holding your birdhouse and screwing it in or putting the pieces together, you may have to get some help. Nothing wrong with that. Alright, so the bottom is in place. Now we just have to do our top, or our roof. So we're going to place our roof where it needs to be. I need to pre-drill my holes. You won't have to do that. So let me just do that now. Just the way the grain is on this wood, it keeps shifting when I pre-drill. What I do, it wants to shift. Is one of the difficulties of working with wood. Oops. All right. This one. So if you're ever working on something in the future and you're running screws in and the wood is splitting, that is the wood telling you that I need pre-drilling. And you need to get a drill bit that's sized correctly for your screw and run that in just like I'm doing here now. Otherwise, if I didn't do that, all this wood would be splitting. Okay, now just to show you something, the wood being the reclaimed wood, recycled wood, the box is just shifted ever so slightly that way. I need to just shift the box over, so pushing here and here on the box, here on the roof, there's a bit of an overhang here. I just want to flush that up. You may have to do the same thing. So that's what I'm going to do. Just find a convenient way to do it. So flush that up. And pre-drill it. We're on the home stretch. 2 screws left. Yeah, so the other thing was when you're installing stuff like this, assembling things, There are times where you can use clamps to help you hold it in place. No shame in that. Lots of different types of clamps out there, from pipe clamps to quick grips to C-clamps. It's all personal preference, and they can help you hold things together. Alright, so there is our assembled birdhouse. At this point, what you're going to want to do is you're going to want to sand your entire birdhouse, cleaning up all the pencil marks that might be on there, if there's any. Helps flush everything up. Feeling along the edges here to see if anything's proud or not. So I've got some pencil marks here I can polish off. I'm not going to sit here and sand this entire birdhouse for you. You get the picture. The last thing to do is put your dowel in for the bird to land on. So we want to just round the end of our dowel off just to make it a little bit less sharp and pointy. The birdies will thank you for it. Okay, doesn't matter what type of sandpaper you've got. Just round the end off just a little bit. Now, this hole is pretty tight, and you might think that it's good enough, but as wood swells and dries, it'll become loose. We need to put some glue in there. So I've got some glue here. This is what I use. It's just carpenter's glue, okay? And it says no heavy clamping required. That's a lie. You always need clamping whenever you're gluing anything together. But what's important is that you get, for this project, you need waterproof glue. In other words, glue that doesn't come apart in the wet, that's the only glue I buy. I won't buy any other type of glue. So just if you're buying glue and you're putting that object outside, it needs to be waterproof glue. Okay, otherwise the rain will get on it and soften it. My preferred, this is obviously very awkward to pour. I use ketchup bottles with the, the no drip lid, and I usually store them like they're designed to be stored. If it's good enough for ketchup, it's good enough for glue. And then all you need to do is a little dab will do you. Just a little dab, little squirt on the bottom of your dowel. Smooth it out with your finger. Goop some in there. And then press and twist in as you go. And there you go. And then a wet cloth to wipe up the excess. I don't have a wet cloth on me this exact second, so I'll just wipe it up with my fingers. I've got some paper towel here just to wipe it off. And then before you walk away, the glue needs time to set. Just make sure that the dowel is set in there straight. You know, house swallows, they're picky. They won't land on this if it's not parallel and perpendicular and straight and stuff. All right. So, that brings us to the end of the project. We now have a birdhouse that the swallows will land in. Hopefully. They have a hole to get into that's sized for them. Certain birds require certain sizes. Okay, we've screwed it all together. So, after you've had a bird nest in one of these, you do want to clean it out. After they move out, they'll move in. They'll have their babies. They'll move out. You could just drop the 4 screws off the bottom and pull it out, clean it out, put the screws back in, and everything is good to go. The only thing left is to screw it up onto a house or a tree or something. Make sure you ask for permission from your parents before you start screwing birdhouses to things. They will make a mess of whatever you put this against. They'll land on here and they'll poop, and that poop's going to land on stuff below. So you definitely want to make sure that you put it in a good spot, so get their help. And you got a couple of screws up here. You can just screw it into a tree or a post or whatever works for them. So I hope you've enjoyed this project, and I hope that you've learned something valuable and useful. As I tell all my students, you can learn how to do these skills and do your own thing and save some money, or you can hire somebody that knows what they're doing. There's no shame in either, but knowing how to fix things and build things is a really important skill, and hopefully you've come out of this with some useful tips.